Thailand's Eastern Economic Corridor is a massive, heavily industrialized coastal zone designed to be the economic engine of the country. Through the Thailand 4.0 initiative, the government has subsidized digital infrastructure in this region, pushing companies to modernize. Despite this influx of capital and clear economic incentives, small and medium-sized enterprises in the corridor are still struggling to adopt big data analytics. This stall in modernization raises a specific question for economic planners. Is the adoption bottleneck a software and hardware failure, or an organizational and human failure? Resolving this requires moving past an IT-centric view of technology. Instead, we have to look at digital transformation as a complex, measurable psychological system. Two major theoretical frameworks explain how technology enters a workplace. The Technology Organization Environment Framework, or TOE, looks at macro-level enterprise readiness. The Technology Acceptance Model, or TAM, focuses on micro-level, individual psychology. By integrating these two models, researchers can map exactly how external enterprise readiness converts into a single employee's willingness to use a new system. This chart shows the finalized structural equation model derived from a survey of 340 SME entrepreneurs in the economic corridor. On the far right is the ultimate endpoint of the entire process, the actual, practical application of big data analytics. To understand why adoption succeeds or fails, we can reverse engineer this system. We can trace the pathways backward from that final application node to identify the root causes of employee behavior. The SEM map transforms digital transformation into a mathematically verifiable pathway. Looking closely at the right side of the diagram, we see the two direct psychological drivers that dictate whether a technology is applied: perceived usefulness and perceived ease of use. The path coefficients connecting these nodes to actual application reveal a clear hierarchy. Perceived usefulness scores 0.278, while perceived ease of use scores 0.218. This weighting reveals that for these entrepreneurs, tangible operational benefits carry more weight than an intuitive system. Since usefulness is the primary driver, we need to analyze what useful means to a mid-sized enterprise using the confirmatory factor analysis data. This table breaks down the internal indicators of the study's variables. In the perceived usefulness block, we see exactly what these business owners value. The indicator for efficiency improvement, labeled PU3, carries a dominant factor loading of 0.995. Compare that to indicator PU5, which represents process monitoring. That factor scores a significantly lower loading of just 0.232. The data paints a specific picture. SMEs adopt big data for immediate, tangible operational efficiency rather than long-term strategic monitoring. Moving backward into the external inputs, we reach the technology node. This measures how baseline technological conditions influence an employee's perception of the software usefulness. The path coefficient here is 0.653, indicating a strong direct effect on perceived usefulness. The data table allows us to unpack the internal indicators of this technology construct to see what specific features matter most. The relative advantage of advanced features carries little weight, scoring a loading of only 0.359. Instead, the construct is driven by big data security, which scores a 0.646. Foundational system alignment and safety are the priorities. During early phases of digital adoption, complex analytical capabilities are secondary. Companies with limited digital literacy prioritize protecting their digital assets and maintaining data integrity. Robust data security and clear system alignment operate as strict prerequisites. If employees do not trust the integrity and safety of the system, they will not engage, neutralizing any potential utility. The final pillar of the integration is the internal organizational environment, represented by the node at the bottom left. The organization node influences both perceived usefulness and perceived ease of use. We can pinpoint exactly what makes this organizational influence so powerful by looking at the specific indicators. Executive involvement drives the organizational node, with management support at 0.841 and leadership capability scoring 0.915. In management theory, the resource-based view argues that a company's competitive edge comes from internal capabilities that are difficult to replicate. In this view, leadership is a quantifiable strategic resource. A visionary leader coordinates fragmented data inputs, allocating resources so the information flows directly into a unified strategy. Proactive management reduces uncertainty on the ground floor. By building a learning-oriented culture, leaders increase how accessible employees perceive new technology. Leadership is the dominant variable governing the entire model. Purchasing sophisticated analytics software will fail without a transformational management structure to drive the internal culture. Zooming out, we can see the entire interconnected ecosystem of enterprise behavior, mapped from environmental inputs down to individual user actions. Following the highest coefficients, the empirical sequence for successful adoption is clear. Secure infrastructure and strong leadership combine to prove immediate operational efficiency to the user. The model fit indices confirm that the structural relationships we just traced are mathematically rigorous. Benchmark metrics such as an RMSEA of 0.032 and a CFI of 0.957 confirm excellent goodness of fit. These results represent highly validated, predictive behavioral patterns of real enterprises operating in a high-stakes economic zone. Bringing this data back to the industrial landscape of the Thai Eastern Economic Corridor reveals a major policy disconnect. Currently, government incentives frequently focus on funding software licenses or hardware upgrades. The data explicitly proves this strategy is insufficient. To accelerate digital modernization, capital must be redirected toward leadership development programs and stringent data governance frameworks. Regional innovation centers could act as knowledge hubs, bridging the leadership and security skill gaps that currently slow these businesses down. Digital transformation depends on the alignment of visionary leadership and secure infrastructure to provide immediate, tangible value to the end user.